In this particular video, we're going to look at some rules of significant figures. When you're doing significant figures, what you're determining is whether there's any zeros in the number that are what are called significant. That doesn't mean that an insignificant number shouldn't be there. It means that measurement-wise, it's significant to your measurement and is an indicator of the precision of the instrument in which you are using. In our first example here, I've broken these down into three different basic rules. And the rules are stating here that you're looking at the zeros basically. So our first rule here is all non-zero digits are by definition significant. So that's the first part of this rule. So 1,458, by definition, all four digits are significant, so the number of significant figures is 4. The other part of this rule is that the zeros that occur between those non-zero digits are also significant. So in 40.7, you have a machine measuring down to the tenths, and this zero then, of course, is significant because it's obviously more accurate than that ones place. So this is an example of a 3 sig fig number. 10,150.01, this zero is significant, and the two zeros occurring between the 5 and the 1. It doesn't matter how many zeros you have in a row. If they are book-ended by two non-zero digits, they are significant. So in this particular case, we have 5, 6, 7 sig figs. Rule number 2 says that leading zeros with decimal points are not significant. That's the first part. So here we have these 4 zeros out in front. These are nothing more than leading zeros, and by definition they are not considered significant. They are just placeholders for the number. So in this case, 0.0005 is a 1 sig fig number. Again, 0.0, non-significant zeros, but the two zeros here are significant from the previous rule that zeros between non-zero digits are significant. So in this case, we have a 4 sig fig number. The second part of this rule is that ending zeros are significant if there's decimal points involved. So here I have a 0 and a decimal point. This machine is measuring down to the hundreds place. So this knows this is not 0.09, it's not 0.11, this is 0.10 exactly. So this 0 is significant. This 0 is significant from previous rule up here that zeros between non-zero digits are significant. So it's between the 7 and the 1, so this 0 is significant, and in this case all 6 are sig figs. Last one, leading zeros, not significant. This 0 is significant because it occurs between the 4 and the 5. These zeros are significant because ending zeros with decimal points are significant. I'm measuring down to that level right there. So our significance starts with the 1, and so we have 1, 2, 3, 4, 5, 6 sig figs. The last rule is about using some kind of indicator or scientific notation to determine the number of sig figs. And the first thing that you should realize is I have the number 15,000 written 4 different ways, and I'm using E notation for the scientific notation. In the first example, you have some device that's measuring down to the thousands place, and unfortunately I don't have enough information to indicate whether I know about the hundreds or the tens or the ones places. So this machine is not super accurate. And a lot of things do this. They'll tick off thousands places sometimes instead of the actual rest of the whole number. This person doing the measurement then needs to report that, hey, I only know information down to the thousands place. And so a number written just like this without any kind of indication says that whatever numbers are out in front of here, that's the only ones I have. So in this case, 15,000 is just a 2 sig fig number. In the next example, I have 15,000 written, but you'll notice it has a decimal point after it. This is a measurer's way of signifying I have a device, and I'm measuring to the actual ones place. And I know it's not 14,999. I know it's not 15,001. It's 15,000 exactly. So that decimal point means all of these zeros are significant, and this is a 5 sig fig number. The other two, if you want to report sig figs to different levels, well, now we need to use scientific notation. I'm using the E notation. So this stands for 1.50 times 10 to the 4th power. That's 15,000. But this person, what you do is you look for the number of digits out in front of the scientific notation part, and there's 3 of them. And this person is saying, I know 15,000 down to the 100s place, and so this is a 3 sig fig number. This person is saying, I know 15,000 down to the tens place. And so this 15,000 is a 4 sig fig number. There are 4 digits out in front of the scientific notation. So I've written 15,000 with 2, 3, 4, and 5 sig figs. Of course, you can't write 15,000 with 1 sig fig because 15 has 2 numbers in them. Now, this skill is actually not all that interesting until you start applying it to some mathematics. So what we want to do is we want to look at some addition, subtraction rules and some multiplication, division rules. Addition, subtraction rules are actually pretty simple. The answer that you get on a calculation in addition and subtraction is only allowed to have as many decimal points as the measurement with the least number of decimal points. So here I have 5.44 minus 2.6106. Your calculator would give an answer like this. But since I only know 2 decimal places here, and I know 4 here, my answer is only allowed to have as much information as my least precise measurement. That's 2 decimal places. So I need to round this off to 2 decimal places. That would be 2.83. Over here, we have 2.4 minus 15.82. That's negative 13.42. But my least precise measurement is only 1 decimal place. So this can only be 1 decimal place. So you would round that off to negative 13.4. 3 decimal places, 5 decimal places. So my answer, of course, is only allowed to have 3 decimal places. So I need to round this off to 2.156. Last one, 0.258 is 3 decimal places. This is 1 decimal place. I add that, I get that, but I'm only allowed to have 1 decimal place in an addition subtraction. And so I have to round that off to 0.4. Now that makes a lot of sense. My answer can't be any more precise than my least precise measurement. Multiplication and division is the same thing, but instead of decimal points, you look at sig figs. The rule here is that my answer to these calculations can only contain as many sig figs, significant figures, as the part of the problem with the least number of significant figures. So in 8.15 times 6, I have 3 sig figs and 1 sig fig. The answer on my calculator is 48.9, but I need to round it off to 1 sig fig. If I round it off to 49, that's fine, but that's 2 significant figures, so I need to round it one more time. So we round it off to 50. A lot of people are prone to write the number 5, but that's not anywhere near close to the answer. It's 50 without a decimal point. If I put a decimal point behind here, that's indicating that I know it to the ones place, and that's a 2 sig fig answer. So it's 50, no decimal point, because I'm only allowed 1 sig fig, and this is a 1 sig fig number. I have 3 sig figs in this number, 0.250, and I have 2 sig figs here. Calculator answer is 0.8, etc. I need to round this off to 2 significant figures, so that would be 0.29. 1.2 times 1010, this is a 2 sig fig number and a 3 sig fig number, so my answer is only allowed to have 2 sig figs. I get 1,212. I can round that off once and get 1,210, but there's a 3 sig fig number. I'm only allowed to have 2, so you round it off to 1,200. 4 sig figs divided by 3 sig figs. My answer is allowed to have 3 sig figs. Calculator answer, 11.3666 repeating. And we have way more decimals than we need. I can only round that off to 3 sig figs, so I round it off to 11.4. That's the multiplication division rule. Here's one you can try yourself. In this one, we're combining everything. Here I have 1.2 plus 0.34 divided by 0.601 minus 0.5. You have to do this in pieces. So you do the top and say, okay, well, I'm going to add the top together, and if you add the top together, you get 1.54. You take the difference on the bottom and you get 0.101. But we have to use the rules of significant figures, and the rules for addition and subtraction are my answer can only have as many decimal places as my least precise measurement. In this case, the 1.2 limits me to 1 decimal point, so that should be 1.5. Likewise, I'm limited to 1 decimal point here, so instead of 0.101, I'm limited to an answer of 0.1. So that brings us to 1.5 divided by 0.1. Now we have a division problem, and we would take 1.5 divided by 0.1, and your calculator would tell you 15. Applying the rules of division, I have a 2 sig fig number divided by a 1 sig fig number. 15 is a 2 sig fig number, but I'm only allowed to have 1 sig fig. So we need to round 15 up to get a 1 sig fig answer of 20. Thank you.